Emostel.
Hello, you're welcome to this video. This is Emmanuel Kadiri. And then in this video, we will continue from where we stopped on this topic, inequalities, intervals, and absolute values. All right, so let's just see how far we can go. The intention of this video is just to brief you on some rules on absolute values and how they connect with inequalities and intervals and everything else. And then we solve a couple of questions, a set of possible questions that you might encounter. All right, so let's drive. Now, looking at this, the very first rule here, okay, we call it the piecewise definition. I've stated those rules in the previous video, okay? The definition have to do with the fact that the absolute value of x is equal to x if x is positive, and then the absolute value of x is minus x if x is negative. All right, so now this one is the square root definition. All of these rules, I just wrote them out because you never can tell. Questions might come out to test you of the knowledge of these rules. Okay, it's not as if you are necessarily applying them, all of them in calculations, but the knowledge of those rules could be tested in one way or the other. Do you understand? So it's very easy to recognize and memorize. For instance, just see this one. The absolute value of negative x is equal to the absolute value of x, okay, for obvious reasons. And then this one, the absolute value, says the absolute value of x is positive, like is greater than or equal to 0, telling us that it is positive, okay, or equal to 0, depending on what value of x, what the value of x is. And then the other one here tells us that when two numbers multiply, okay, the absolute value of the product of two numbers is the same thing as the absolute value of the individual numbers, okay? So, which means if I have the absolute value of 2x, okay, is still the same thing as the absolute value of 2 multiplied by the absolute value of x, okay? So, in case there is a content or there is anything there, for instance, if 2 was negative, like absolute value of minus 2x, you will still have the absolute value of 2 multiplied by the absolute value of minus 2 multiplied by the absolute value of 2. Or you use this rule, and then at the end of the day, the answer will still become positive 2x. Okay? So, this one is just trying to tell us that when two numbers are dividing, the absolute value of the quotient of two numbers is the same thing as the absolute value of the numerator divided by the absolute value of the denominator. We call it the quotient rule. Okay? Then here, this one tells us that the absolute value of x raised to power n, for instance, the absolute value of let's say 2 raised to power 5 is the same thing as the absolute value of 2 then raised to power 5. So that by the time we first get the value of the absolute value of 2, then we can power it. Okay? All right. So it's applicable in cases like, for instance, if we have something like, let's say, we have a number like absolute value of 3, of minus 3, of negative 3, raised to power 3. The absolute value of negative 3 raised to power 3, okay? If we have something like this, applying this rule means that we are going to say it is the equivalent to absolute value of 3, of negative 3, then whatever the result is, then we now power the result. So in that case now, it is going to be the absolute value of 3, of minus 3 itself, which is going to give us positive 3. Eventually, then positive 3 raised to power 3 will give us 27. Do you understand? So that is how it goes. But if this absolute value symbol was not there, the result of negative 3 raised to power 3 would have given us negative 27, because it would have meant minus 3 times minus 3, then times minus 3. So minus times minus is plus, okay? Then plus times minus is minus. Then 3 times 3 is 9, 9 times 3 is 27. it have given us negative 27. Okay, so just get it like that. And then the next rule here is saying that, and this rule is very important for you to take note of. It is absolutely different. Don't say because the absolute value of the product of two numbers is the same thing as the absolute value of the product of the individual absolute value of each number. That doesn't apply to plus and minus. Okay, so you don't say because it applies to multiplication, then the same thing would happen here. So we say, okay, absolute value of x plus absolute value of y. No, it doesn't go like that for addition and subtraction. Tested, like I just don't have the time to test this thing for you. I have personally tested them, okay, especially this, okay. I've tested this rule, but for you to please understand this rule, because this rule involves inequality. Like the absolute value of x plus y is less than or equal to the absolute value of x plus the absolute value of y. So when you have plus here, you are going to have less than or equal to. But when you have minus, you are going to have greater than or equal to. It gets why. Okay, there is a reason why it happens like that. Okay, and I have tested it. If you can slot in numbers, to test this rule. You will see that it works. In fact, slot in numbers that will deliberately give you negative results. Okay, maybe you make x to be minus 2 here, and then you make, maybe let's say y is 4. Okay, let's say y is 4. So the absolute value of minus 2 plus 4, expectedly, okay, if you solve minus 2 plus 4, for instance, minus 2 plus 4 is going to be like positive 2. Okay, then the absolute value of positive 2, let's see whether the result is going to be the same here. So when like, if you check this out now, the absolute value of 2, of minus 2 will give you normal 2, then minus the absolute value of 4 will give you 4. So 2 minus 4 gives you minus 2 here. So you see that we got 2 here, positive 2 as a result here, but we got negative 2 on the other side. So is positive 2 not truly greater than negative 2? It is. Do you understand? So like slotting values, you always get it, okay? Or just no time because of the exam and all that. And I understand you have the paper today, and so I just have to be very brief with some certain things. So just be aware of these rules. They are very important, okay? All right, so you can take note of them. You can just write them down, pause the video, write them down, because I'm going to erase all of these things now for us to be able to solve these questions here, okay? So these questions here are also important. They could set questions like this for you. You need to know how to handle questions like this whenever you come across them, okay? So, a very quick one. Okay. All right, so let's quickly get on with question number 1. For the question number 1, all right, if you want to solve this, you have minus absolute value of minus 3. Okay, good. Now, just take note of the fact that this negative number here is on its own. No, it's not part of the absolute value setting. It's just outside there on its own. Then you are dealing with whatever is it inside here. The absolute value of 3, according to the rule, okay, so let's just repeat this one. This minus here, we repeat it. Then we open a bracket so that we can be able to get rid of whatever is going on here. So the absolute value of minus 3, as we know the rule, as the rule implies, is going to be equal to minus of minus 3. Because the rule says the absolute value of x is what? Is equal to minus x if x is a number that is less than 0, which means if x is negative, then the absolute value of x is going to be minus x. So we are regarding this one as x. So x is what we put here. Then the minus here is the minus that came with this rule. Meanwhile, x is minus 3. We put it here as x. then the negative here is the negative here. Then the negative that we have being outside here is the negative of this one. I hope you are getting it. So as you have all of that now, then you're going to have minus. The minus times minus is plus, okay? Positive, right? When it's positive, we don't necessarily need to write it. So minus times minus is plus. So then at the end of the day, this minus outside here just patiently waited to make this guy to finish all the old thing he wants to do and then deal with this. So minus multiplied by positive 3 will give us negative 3. So the answer of this particular question is minus 3. Normally, the result of absolute value is always positive. So which actually end up being positive here. But the minus sign that we have here does not have business with the absolute value result. It's only waiting for whatever comes out of this result of the absolute value so it can multiply it, and then that is the reason why the answer of this one ended up being negative. Okay? All right, so now if you don't understand, please you can message me. I will explain again and much more slower. Okay? But I believe with the knowledge of what you have treated in previous videos, you should be able to know exactly what is going on here. Okay, number 2. Now, for the number 2, we have this 2x plus 1, then greater than 5. There is a rule in absolute value, like one of the rules we treated in the previous video. I didn't list it. I didn't enlist it among the rules here that I listed here because I've stated it before, and not because I've stated it before, but I forgot to add it to it because the first 2 rules, I've stated them before, then I still added them. Okay, so but remember this rule which says that, okay, which involves the rule of inequality. Okay, but then instead of that rule is applicable also when we have this kind of thing here. Now, what you are going to do in this case here now is that you have, I'm going to have to rub this off. Okay. Remember the rule in the previous video which says that if the absolute value of x, okay, is less than y, okay, the rule says minus y will become less than x, then y, okay, less than y. Remember this rule that says if the absolute value of x is less than y, okay, so what you do is that you convert it to inequality. In that case, it means the range of value of x is going to be between negative y and the positive y. Okay, it's going to be minus y less than x less than y. I explained the reason why this happened in the previous video. All right, so but this question now is talking about a case whereby it is greater than y, like the absolute value of something is greater than something else. So in that case, it is just easy for you to see. Therefore, if we have absolute value of this is greater than this, then in that case, it is easy for you to just switch it the other way around and say minus y is greater than x, then greater than y. So the direction of the inequality will follow suit, just as it happened in this place. You get that? So if we apply that rule here, we are going to have something like minus 5, okay, is greater than 2x plus 1, then greater than 5. Okay? Now, after we have this one here, the next thing to do is to find all ways to make ordinary x to stay in the middle, and then we have ordinary numbers on the other side, so that it can look like a standard inequality. You know, inequality would be something like, let's say, minus 2 less than x less than 5, or something like that. You understand what I'm trying to say? So in the standard representation, it is only x that stays in the middle. In the standard representation, only x stays in the middle. The other numbers, the other sides will be just numbers, okay? Like the numbers that will be represented on the number line. That is the same thing that we are going to do here, right here. Okay, so we are going to find everything mathematically possible to make us have a situation whereby only x is staying in the middle, and then the other things, the other side will be just numbers, okay? Now, how do we undo that? We undo that by Finding means to remove every other thing that is disturbing x. For instance, plus 1 is disturbing x, right? If I want to remove plus 1 here, what I would do, because this one is multiplication, I need to deal with the lower one first. Then I will now get to the higher one. You know, in the rule of board maths, we have bracket of division, multiplication, addition, and subtraction. So multiplication came before addition and subtraction, right? So, but because I'm coming from the back forward, I'm going to sort out the addition part of it, then multiplication part of it, because 2 is multiplying x, but here 1 is adding to 2x, okay? So let's deal with this one first. Then when we deal with this one, we come to that of multiplication. So how do we get rid of plus 1? The easiest way is that you subtract 1 from all sides. You subtract 1 from all sides, okay? So subtracting 1 from all sides, you have, minus 5 minus 1. Then we have 2x plus 1 minus 1. And then we have 5 minus 1. So minus 5 minus 1 will give us minus 6. Then we have minus 1 plus 1 is 0. So we have 2x remaining. And then this one, 5 minus 1 will give us 4. Okay? 5 minus 4 will give us 4. Okay? Now, as you have it this way, you continue. The next project is to deal with these two, to get rid of these two. We don't want to see these two here. So since we don't want to see 2 here, one of the best way, and 2 is multiplying x, so you use the opposite of whatever is happening there to deal with it. You know, in the other one too, 1 was adding to x or 2x, okay? Then we wanted to get rid of this one, then we subtracted 1. So we apply the opposite of plus 1 to remove 1. So in this case now, we are going to apply the opposite of times 2 to remove 2, which is divided by 2, okay? So which means we are going to divide all sides by 2, just because we want to get rid of this. So we have minus 6 divided by 2, greater than 2x divided by 2, then greater than 4 divided by 2. So this get rid of this, we have minus 3 greater than x, then this greater than 2. Okay, so at the end of the day, we have minus 3x greater than x greater than 2. So we are able to arrive at an appropriate inequality. Okay, now how do you represent this for real? Okay, because the standard way of representing an inequality is like less than something, less than something, less than. So that's how to represent the interval. But in this case now, we are having everything facing that side. Well, you can keep your answer in a simpler form by switching, okay? So, you know, if you can split it, minus 3 is greater than x, but x is greater than what? Than 2, okay? If we switch this one now, it means x is less than minus 3, okay? But x is greater than 2. So, which means that the regions that satisfy this inequality, if you have a number line, the regions that satisfy this equality are the regions of x, the values of x that are less than minus 3, and the values of x that are greater than 2. So if you have minus 3, you know, let's say we have 0 here, let's say we have 2 here. You have 2 here, okay? This is like negative infinity, positive infinity, and this is like the line, the values of x, okay? So now we are going to, x is less than minus 3, so you go like this, less than minus 3. Because it does not carry equality, you're not going to shade it. Then this one is like x is greater than 2. So you are going to keep it this way, like this. So which means the region of the number line that satisfies this inequality is all values of x that is less than 3 and all values of x that are greater than 2. So any place between these two does not satisfy this inequality. All right, so that is that. So every value, now if you want to put a test, okay, let's see. Let's assume x is something like -2. If we slot in -2 here, we are going to be having absolute value of 2 and times -2 plus 1. Let's see if it is truly going to be greater than, going to give us a number greater than 5. So 2 times -2, that will give us -4. -4 plus 1, -4. If I'm owing 4 and I'm having 1, then that means -4 plus 1, that's 3, -3. Okay, so we now have absolute value of -3. Okay, now if you have the absolute value of -3, and then you slot it into this this equation. Sorry, I need some free space. I believe I can. Okay, let me use this place to test. Okay, so we are looking for all the regions of x that satisfies this inequality. So to look for the regions of x which satisfies this inequality, we are going to have like this: 2x plus 1, okay? And then we have greater than. We want to see if it is going to be truly greater than 5. So let's see how it goes. All right. Now, let's take any value of x that is less than -3. Let's say -4. Okay, -4 is less than -3. I mistakenly chose something else earlier. I'm sorry. I must slept for like 24 hours, and just to make these videos, please, just I beg your pardon. Now let's get for real. -4 is less than -3. Is one of the values less than -3. So let's put so which means we are going to be having absolute value of 2 times -4, then plus 1. Okay, so 2 times -4 will give you -8. So you have -8 plus 1. Okay, -8 plus 1, that will be like I'm owing 8, then I'm having 1, and then that's going to be -9. So what's up with absolute value of -9? Absolute value of -9 is equal to 9, as we know, because according to that rule. So absolute value of -9 is equal to 9. It turns to +9. And then is 9 truly greater than 5? Yes, it is greater than 5. Test any other value like that, you keep getting results greater than 5. Okay? Now, but then if you test every value too, from 2 upward, okay, you keep getting answers that are greater than 5. So let's try it. If, for instance, we have, something like, let's choose a number like 3. So so we slot it in, absolute value of 2x plus 1. Let's see if it's going to give us a result greater than 5. So when x is maybe a number like 3, so you put it there, 3 plus 1, absolute value. 2 times 3 is 6, 6 plus 1 is 7. Okay, absolute value of 7 is also equal to 7. Is 7 greater than 5? Yes, it is. Now, let's see whether if we choose any other value between this region, if it will give us a result that is truly greater than 5. Let's see. Let's choose a value like -2. A value like -2, okay? Within this region, a value like, this is like -2, -1, 0, and all that. Let's choose -2. If you choose -2, we are going to be having absolute value of 2x plus 1, like this. Then we have absolute value of 2 -2 plus 1. Absolute value of 2 times -2 will give you -4 plus 1. So -4 plus 1 means I owe 4 and I have 1. So if I pay the 1, I'm still owing 3. So absolute value of -3 is going to be equal to 3. Is 3 greater than 5? No. You see that mathematics does not lie. So which means that the regions of the real numbers or the values of x that satisfy this inequality are all regions of x that are less than 3 and then greater than 2. Anything in between here will not give you any result that is greater than 5. It won't. So you can experiment with other values on your own, and you will see that you never get any number greater than 5 if those numbers are chosen between this region and this, between this blank region. None of them will ever be greater than 5. And that is it. So remember that the direction of the inequality is what determines the direction of how you place this thing on both sides, okay? So recall the rule. The rule says that if the absolute value of x is greater than y, we started with the one less than y, okay? It says therefore, it says then minus y is less than x, then less than positive y. But if the absolute value of x is greater than y, the same thing applies. Minus y, okay, minus y will be greater than x, then greater than positive y. So that is it. That is the rule that was applied to solve this question, and then everything was still correct. All right, so let me just take this off. You might want to pause the video, okay, so that you can rub it off. You can write things down before I rub it off, okay? All right, so let's go on to the third one. The third one says 0 is less than or equal to 4x minus 1, less than or equal to 2. Then we want to solve this inequality, okay? How do we solve this inequality? It's very simple. Anyway, the same thing we did in the previous question is what you're going to do here. We keep doing everything mathematically possible until we will achieve a result that looks like a less than equal to x, then less than equal to b, until we achieve something like this. We keep reducing everything that is around x until it reaches this kind of stage. So that is what we do. So how do we get rid of that now? In this case now, okay, we first deal with this minus 1. And how do we deal with the minus 1? You say you add 1 to all sides. Anything you see there, it is the opposite of it that you do in order to remove whatever is there. You get it? So if I'm to add 1 to all sides, then it means 0 plus 1 less than or equal to 4x minus 1 plus 1 less than or equal to 2 plus 1. So I'm adding 1 to all sides just to eliminate this guy, minus 1. If it was plus 1 that was there, then it means I will subtract 1 from all sides. But because it is minus 1 that is there, the opposite of minus 1 is plus 1. So you understand, the opposite of anything you find there is what you apply. But you don't only apply it there, you apply it to all sides so that everybody will have equal share. Okay? So now we have this as 1 less than or equal to 4x minus 1. Okay, sorry, 4x minus 1 plus 1 is 0, so that one is gone. Then this one becomes 3, okay? So as it is 3 now, 2 plus 1 is 3, right? Yeah. So as it is 3, the next thing you do, you want to get rid of this 4. So to get rid of this 4 now, okay, is to divide all sides by 4. Divide all sides by 4. So that will be 1 divided by 4, less than or equal to 4x divided by 4, less than or equal to 3 divided by 4. I divide all sides by 4 because I want to remove this 4. If the number there was 2, then I will divide all sides by 2. And why am I using division? I'm using division because the relationship between 4 and x is multiplication. And it's only division that can make that 4 to disappear. If it was dividing before, then I will multiply. Just the opposite of the operation that you find there is what you apply in order to get rid of your target. Okay. So at the end of the day, we have 1 over 4 less than or equal to, this cancels this. We now have x less than or equal to 3 over 4. And so that is the answer. So which means the region of x that satisfies the inequality is what? All regions of x like 1 over 4 of between, if you split it, you can split it as 1 over 4 less than or equal to x, all right? And then you put this one here, as x less than or equal to 3 over 4, and then you can turn this one to the other side and say x is greater than or equal to 1 over 4, okay? And then x is less than or equal to 3 over 4. So it's quite simple. You can draw a number line for these two and represent the fraction on the number line. Okay, you know 1 over 4 is the same thing as 0.25, okay? And then like that. So if you want to represent it on a number line, 3/4 2, okay? So there's no time. Just, you know what I'm trying to say. You can represent it on a number line and all that, but the beauty of it is just for you to know how to solve the equation and then do whatever the question asks you to do. So let's just quickly run to the next one. I'm rushing because we still have more videos to cover. So we have 5 greater than 2 minus 9x, and then we have minus 4, okay? So to go on with this, what you do here is that you just do the same thing that you've been doing. Find every means to remove whatever is it that is disturbing the x, just to achieve this kind of picture. The very first thing that you're going to do now is, because 2 is here, so you subtract 2 from all sides because it is positive, so you apply the negative 2. So you say 5 minus 2 greater than 2 minus 2, okay, then minus 9x greater than minus 4 minus 2. So at the end we have 5 minus 2 will give you, 5 minus 2 is 3, then greater than 2 minus 2 is 0, so we have minus 9x, and then we have this as what? Minus 4 minus 2, that is minus 6. Okay, so looking into this one, the next thing is to divide all sides by minus 9. Okay, subtract 2 from all sides. Yeah, so dividing all sides by minus 9 will give you 3 divided by minus 9, okay, greater than minus 9x divided by minus 9, and then greater than minus 6 divided by minus 9. Okay, so final answer, we have 1 divided by, we have minus 1 over 3, greater than this, greater than x, then greater than positive 2 over 3. And so that is how we get it. Because 3 goes in 6, 2, 3 goes in 9, 3. Okay, and so we have that result here. Or you can say x, is greater than, you can say x is less than minus 1 over 3, but x is greater than 2 over 3. Okay, if you want to even represent this in form of interval, yeah, you feel you are free. Okay, so to represent this kind of results, like the kind of results we had in the first example we did, where we had the two guys facing other side. If you want to represent it in form of interval, you can do it in form of sets. For instance, let me just quickly show you that. Let me show you that, how to do that. Okay, a quick one on how to solve that is that if, for instance, okay, the result we got earlier was like this. I think we had a number line. I think the first one is minus 3, and this one is positive 2, and we have this like this. Okay, so to show this result in form of, to present the result in form of intervals, okay? Remember that the two of them are open intervals, so which means this one is just less than and this is greater than. Okay, this is positive infinity, this leads to negative infinity, and then this is just a number line for x. You know, the origin O will be somewhere around there, but no problem. So, if you want to represent this, remember that what bettered this is that x is less than minus 3, and then x is greater than 2. Okay? Now, if x is less than minus 3, and x is greater than 2, which means that the range of x is going to be like all values from negative infinity up to 3, open interval. Reason why we are not using closed interval here is because of the fact that it's not carrying equality. Assuming it is equal to 3, then we have a closed interval. So, which means this one represents the range of all values from negative infinity, okay, up to 3, but 3 exclusive, 3 excluded. Then this one represents all values, okay, from 2 to positive infinity, okay, to positive infinity from 2 and above. That's what this one represents. So which means the lower limit is 2, and then the upper limit is infinity, okay? But then because 2 is not inclusive, if assuming 2 was inclusive, it would have been like this. But because 2 is not inclusive in that range of values, so we have it as an open interval, okay? And you know infinity is always open interval, okay? There's no, because we don't know the last number, there's no closed interval for infinity. So you just leave it, just leave it this way, and then that as per that, okay? All right, so you now put a union between them, okay? Which means the set of all values that satisfy the inequality are all values from -3 downwards and all values from 2 upwards. So the union of those two is what satisfies this inequality. So you can represent it this way if the question wants you to represent it in form of intervals instead of in form of graph, okay? Or instead of in the form of inequality. So in the form of inequality, it's going to be like -3 greater than x, then greater than 2. So this is in form of inequality. This is in form of number line, and this is in form of what? Interval. So anyway the question comes, you should know how best to run it. So I'm not going to waste time on this, okay? So just sort this one out because of time, okay? It's the same thing. What we are going to do here, we put -2 here, -2 less than the whole thing here, then less than 2. And then you find all ways to remove every jagbajantis that is disturbing x. First thing you do is to multiply throughout by 5 to get rid of that denominator 5. Then when you multiply everywhere throughout by 5, you subtract 3 from all sides. Then you divide all sides by 2. And then x alone will be staying in the middle. And that is just it. You can play around that yourself. All right, so I just have to end this video ASAP because of the other videos that we must do before it is time for the exam. All right, because you also need the time to watch it and also solve some questions too. And that is that as per that. And so don't forget our 4 keys. You need to learn, you need to understand, you need to apply the understanding or the knowledge, okay, by practicing. And then the next thing is doing the first 3, you must excel. So your excellence is our priority. And that is why we are going through all this, to make sure that you have very beautiful exams. All right, see you in the next video. Bye.